Hi. We are at a point in our geotechnical engineering course in which we have covered many important properties of soils. Now, in many geotechnical projects, we need these properties, these mechanical properties, these hydraulic properties, because we're going to use the soil as construction material in embankments, in dams, in walls. So this is a good point to introduce a new type of geomaterials that are called geosynthetics. This is because the properties of these geosynthetic materials have been tailored so that we can replace, in many cases, the soils as construction materials. Let me step back and look at the world of geomaterials. The geotechnical materials that you as a civil engineer will be dealing with in the design, the construction, the operation of geotechnical systems. An easy way to classify our soils is by their particle size. So we have seen gravels, and they are the particles that exceed 4.75 millimeters. And they are good drainage materials. Then we have sands that are smaller than gravels, and as the gravel, the mechanical properties, the hydraulic properties are heavily influenced by their density, by their confinement. Then we get the fines. The fines are particles that are below 75 micrometers, and the silts are not so pervious as the sands, not so impervious as the clay. So these are particularly good for agricultural purposes. And then we get into the clays. By particle size definition, they are the particles with sizes below 2 micrometers. But the most important aspect that governs their properties is that most clay particles are also clay minerals. The mineralogy of the clays is what governs the hydraulic, the mechanical properties of clays. Now, we have a new type of geomaterials, the ones that we're going to cover in this class, which are the geosynthetics. The use of inclusions to improve the mechanical properties of soils dates back to ancient times. Do you recognize what this picture is? These are relics of what we would call today a reinforced soil system, but it turns out that these are relics of the Great Wall of China, built over 2,200 years ago and has endured the passage of time. These are relics from the Han Dynasty. This is in the northwest of China in the Gansu province. This system constitutes what today we would call a geosynthetic reinforced soil system, but they used natural geotextiles at the time. Now, we may have forgotten the concept of reinforced soil systems, even though it was very nicely used over 2,000 years ago. And we reinvented it in the 1960s. We started using this concept of soil reinforcement with steel strips. Now, around that time, actually in the 1950s, is when a revolution in material science started occurring. And this is the advent of polymers. Actually, what we call today high-density polyethylene was registered in the 1950s. And here we see in the 1970s a huge display of geosynthetic being used for impermeabilization as a barrier system to mitigate the migration of liquids into the subgrade. So geosynthetics started being used as impervious barriers, but also for filtration, for separation, and for the reinforcement that we have seen in the Great Wall of China. This is an impressive structure today. This is what is called a mechanically stabilized earth wall, built recently in the Indian Himalayas to construct the Sikkim airport. They needed a comparatively flat area for the runway in this very hilly terrain. So they ended up building this 70 meters tall reinforced soil wall. This is a system that is so big that it's difficult to take a picture of. So here you see three levels, three terraces of reinforced soil system, but you do not see that behind this facade there are very high strength geosynthetics to provide internal and external stability to this retaining wall, but also you do not see traditional terraces going below this view of the picture. And also what you do not see is that this was taken during construction, so there are 3 additional levels in this structure. This is probably the tallest geosynthetic reinforced wall in the world today. But not only we see impressive structures like the one in the Sikkim airport, we also have everyday structures. If you drive by your city, you will see structures like this. This one, Austin, Texas. So we are able to construct not only the impressive structures, but also very cost effectively some of the conventional structures that in the past we may have built with concrete, for example. This is what is called a segmental retaining wall system. So what are geosynthetics? We can define geosynthetics as polymeric materials that are specifically manufactured to be used in geotechnical and geoenvironmental applications. So what makes a textile become a geotextile is its use. A textile like this, if it was manufactured for use in a geotechnical project, it becomes a geotextile. I would say that this is primarily polymeric materials, but in some cases we see other materials such as natural materials being used also as geosynthetics. They have very important characteristics. In particular, they are quality control manufactured. So in a manufacturing facility, in a factory environment, that's where these products are made, and consequently they are tailored to have very specific mechanical and hydraulic properties. They are also going to be installed very expeditiously, which is very important in many construction projects. They are generally used to replace earth and construction resources in a significantly smaller volume. And in doing so, they contribute significantly to sustainability in the sense that the carbon footprint of alternative projects, one constructed with and the other without geosynthetics, will have very different carbon footprint, with a geosynthetic project being more sustainable. The same way that we have seen the different soil types, we need to identify what are the different geosynthetic types. I'm going to just list them here first, and then in the rest of the lecture, I'm going to go one by one with some additional characteristics. So here's a list. Geotextiles, or GT. Geogrids, or GG. Geomembranes. Along with geotextiles, these are probably the 2 most common types of geosynthetics, or GMs. Geonets, or GNs. Geocomposites, or GCs. Geocells. Geosynthetic clay liners, or GCLs. Erosion control products, a type of product that is fast growing in the geosynthetic industry, and many others. I'm listing only some of them. Others are geofibers, geofoam, geopipes, geosynthetic that are used as paving interlayers. Let me get now and list for you the different geosynthetic functions. Identifying the correct functions of geosynthetics is very, very important because they are key to define the properties of the geosynthetics, and eventually this is the reason why we're going to use them to replace some of the earthen materials. So I'm going to just list them for you. Some of them are going to be mechanical functions: separation and reinforcement and stiffening, also known as stabilization. Then we have filtration and barrier and drainage. These are hydraulic functions. We're going to get back to each one of them later on. Let me add one more: protection. And for context, let me bring back what are the relevant soil properties, because these different functions are going to be the gateway to the geosynthetic properties. And these geosynthetic properties in many cases are equivalent to some of the geotechnical properties of soils that we have learned in this class. And they include some physical properties, specific gravity of solids, the void ratio of soils. Some of them are going to be compositional properties, the characteristics of the grain size distribution, coefficient of uniformity, coefficient of curvature. Some of the characteristics of clays, plasticity index, moisture content. The plasticity index is really a surrogate for the mineralogy of clays. Then we have hydraulic properties, the hydraulic conductivity, the coefficient of consolidation, the porosity of soils. Then we have mechanical properties, including the properties that correspond to the compressibility of soils and the properties that correspond to the shear strength of soil, the cohesion, the friction angle. We denote it as delta when we refer to interface friction angle, the end-range shear strength of the soil. So in summary, we have a new type of material within the family of geomaterials. They are synthetic, they are typically polymeric, and they are used to replace many of the functions that have been typically fulfilled when we use soils as construction material.